Good morning, students. Can you hear me? Yes. Okay, thank you. Let's wait a couple of minutes till others join in because today we are going to do a very important lesson which have a higher weightage for your exams as well, which is much relevant to the financial aspects of building economics as well as some mathematical background. I hope you can see my screen as well. Okay, I think we can start now. I hope you can see my screen as well. Am I correct? Can someone confirm that you can see my screen as well? Yes, okay, thank you. Thank you, Lakshan. So today we are trying to continue the lesson that we were doing in the last day, that is regarding the economic performance analysis for buildings. So in today's lesson, we are mainly focusing on the life cycle cost analysis, LCA, or life cycle costing. So what do we mean by life cycle costing? Life cycle costing or whole life costing, in other terms, we call it as whole life costing, is the process we use to estimate how much money we will spend on an asset over the course of its useful life. So we are not only considering about the initial cost or the purchasing cost of a particular asset, but we are also focusing on the whole life costing. It includes all the maintenance costs. It includes the initial cost or the purchase cost. It includes the um, maybe initialization costs. Likewise, we basically focusing on all the costs, including the whole life of that particular asset. So in this whole life costing, it covers an asset's cost from time you purchase it to the time you get rid of it. So it basically covers all the cost incurred from the time you purchase it to the time you decided to get rid of it. So that is why this life cycle costing is very important, because most of the cases the initial cost will not, or the purchase cost or the cost in the price tag will not give us a proper understanding on the total cost of this particular purchasing of this particular product or the service. So in order to have a better understanding on that thing, we need to focus on the life cycle cost. So in life cycle cost analysis, you can see in terms of a construction life cycle, the initial cost is just the tip of the iceberg. So it basically shows a part of the total cost, not the full. We might have higher costs which is incurred with or included with that particular construction project, which does not imply by the initial cost. So you can see in this diagram, the initial cost is just like the tip of the iceberg. So we have in in down of this initial cost, we have the operating costs, we have the maintenance cost, we might have replacement cost or disposal fees. So these costs will not included into this initial cost. But whether when we are deciding whether to go for this construction project or not, we should not only focus on the initial cost. We should focus on the other costs included or other costs that are relevant to this particular uh, project as well. So in very simplest way, the life cycle cost can be identified or calculated using this formula. This is not the only formula that we can use. This is the simplest format of the formula that we can use. So the life cycle cost is equal to C is representing the initial cost plus recurring cost. What do you mean by this PV? The present value. If you remember, we learned about the net present value in previous lessons. So we should identify the present values of future costs. Whatever the recurring costs we have in future, we should convert it into the present value. Minus, at the end of the period, we might sell that particular product. Or maybe we might, like for an example, let's say you are hiring or you are buying a vehicle to your construction company. So at end of another 5 or 10 years, you might sell it to someone who buy it. So in that case, it is a residual value. If at the end, it will not be a cost, you are selling it and making some money. So that money should be minus by these costs. So by that time, even though that particular the good or the service is valued a certain amount, it will not be the actual amount if you convert it into the present value. Therefore, we should identify the present value of the residual values as well. Are we clear up to this point? Because these things are very important in terms of the life cycle cost analysis. Anything that you need to clarify? Nothing? Okay, it seems you have no questions up to this point. So moving forward, so in order to compute the life cycle cost, there are several steps that we need to follow. First one is we should identify the alternatives. So if we have several alternatives to do a particular job, so we should identify what are those alternatives. Then after identifying those alternatives, we should define the cost elements for each and every alternative. Those cost elements may include the purchase cost, the installation cost, the operating cost, the maintenance cost, and whatever the financing, for an example, interest or depreciation, and the disposal cost. Those are not limited to these elements. There can be some other elements as well. So you need to identify the relevant cost element based on the situation. So first of all, we identify the alternatives, then we identify or then we define the cost elements for each and every alternative. Then we can determine the time for each cost element. Time for each cost element in the sense we should have proper understanding on the present value of those cost elements. So in order to have a present value estimation, we need to know the time. Based on that only we can estimate the value of each of the cost element. Here we are estimating the present value of each cost element. Fifth, calculating the net present value of each cost element for every year over its time period. Let's say for an example, a particular uh, product or service is last for around 5 years. So we should calculate the net present value of the each and every cost element of that particular product or service throughout the 5 years in each year for every year. After that, we can calculate the life cycle cost by adding all the cost elements together at every year. Then only we can do the analysis in order to identify the most profitable alternative or the most preferred or most suitable alternative to be used. So these are the common steps that you can follow in order to identify the life cycle cost. But remember, when we are identifying the life cycle cost, we should clearly identify the cost elements. Those cost elements are not limited to these 6 or 7 listed here. You might be able to identify some more cost elements. So depending on the situation or the question, you should identify those cost elements. So what are costs? Actually, there are numerous costs associated with a building project for acquiring, for operating, for maintaining, and for disposing a building. So it's not only the acquisition cost or the purchasing cost. We should focus on the operating cost, maintenance cost, as well as the disposing cost. If there are some other costs related to this building project or the building construction, we should focus on those costs as well. So these building related costs usually fall into these categories. We can subdivide these building related costs into the initial cost, that is the cost for purchasing the building or maybe for the land acquisition as well as for the construction. Then we can have some fuel costs. Here the fuel includes the gas, utilities and all. And we may have some operation costs, maintenance costs, and the repair costs. So then and there we might have some repairs to be done, some maintenance work. So these cost items should also be considered. And if we need to replace something in our building, so we might have some replacement costs. And the residual values, that means the resale or salvage values or disposal costs. Salvage values or the resale values or the disposal costs in the sense, resale or salvage in the sense, it means at the end of the time period, if we sell the particular construction to another party, whatever the amount of money that we receive is the resale value or the salvage value. The disposal cost is at the end of the life period or the a particular period, if we thought of disposing the particular construction or building, it will be the cost included or associated with that particular disposal. The finance charges, the loan interest payments should also included under this cost. So we might have some, we might have taken some loan in order to do this construction work. That particular loan interest payment should also be included into the costs. And there are some non-monetary benefits or costs. So those non-monetary benefits or costs should be converted into a money value and included under these cost elements. So these are some of the building related costs, but importantly, these are not limited to these set of costs. There can be some more costs associated with these building related cost elements. So we'll start with the initial cost. So initial costs may include the capital investment for land acquisition, maybe for the construction of the building, or maybe for the renovation and for the equipment needed to operate a facility. In the land acquisition costs, it need to be included in the initial cost element if they differ among design alternatives. So we should include the land acquisition cost in the initial cost estimate if they differ among design alternatives. So this would be the case for an example when comparing the cost of renovating an existing facility with new construction on purchased land. So whether to renovate an existing facility or whether to go for a new construction on purchased land should be considered under this initial costs. In the construction cost, the detailed estimates of the construction costs are not necessary for preliminary economic analysis. We might not be able to have a detailed estimates of the construction costs at the very beginning. Therefore, for the preliminary economic analysis, it might not be necessary to have the detailed estimates, but when analyzing the alternative building designs or system at the first stage or the preliminary stage, we might not need, but later we might need. So such estimates are usually not available until the design is quite advanced and the opportunity for cost reducing design changes have been missed. So if we put the detailed estimates of construction costs at the very beginning, what happens is there's a high chance of missing the reduced cost with design changes. So this LCCA life cycle cost analysis can be repeated after we have detailed estimates as well. Any questions? Do we have anything that we need to clarify regarding the initial costs? If not, we can move forward. Then the energy and water costs, or maybe we can categorize them under the fuel costs as well. The operational expenses for energy, water, and other utilities are based on the consumption, current rates, and the project or the price projections. Because the energy and to some extent the water consumption and building configuration and building envelope are interdependent. Interdependent in the sense they have a relationship in between them. Energy and water costs are usually assessed for the building as a whole rather than for individual building systems. So we normally assess the energy and water cost for the whole building rather than assessing them to each and every part individually. Then further, the energy usage or the energy costs are often difficult to predict accurately in the design phase of a project. So we can't actually predict the energy costs at the design phase of a project. Assumptions must be made about use profiles. So we don't know how the occupants will use that particular energies. So we might have to assume them. We might have to assume the occupancy rate and the schedules, all of which impact the energy consumption. So this energy consumption is highly related with the user profiles, occupancy rates, and the schedules. Therefore, at the very beginning, at the design stage, we might not be able to have a better prediction over these occupancy rates, user profiles, and the schedules. That is the reason we might need assumptions to make these energy and water costs at the design stage. But at this same time, at the initial design stage, data and the amount of energy consumption for a building can come from engineering analysis or maybe from some computer programs. So we can use some tools, some engineering analysis tools in order to predict the energy and water costs at the initial design stage. Okay. Moving forward, then we have the operation, maintenance, and repair costs. When it comes to the operation, maintenance, and repair costs, non-fuel operating costs and maintenance and repair, we call them as OM and R. Operating stands for O, M stands for maintenance, R stands for repair. OM and R costs are often more difficult to estimate than the other building expenditures because operating schedules and the standards of maintenance vary from building to building. So whatever the schedules to have these operations as well as the maintenance varies from project to project or the building to building. There's great variation in these costs even for buildings of the same type and age. So even if we consider two buildings with same types and same age, there can be a variation for these OMR costs, operation, maintenance, and repair costs. It is therefore especially important to use engineering judgment when estimating these costs. So it is therefore especially important to use the engineering judgment when estimating these costs. Next, we have the replacement costs. In replacement costs, The number and timing of capital replacements of a building system depends on the estimated life of the system. So let's say if the building is estimated to be last for 20 years, and the replacements might be scheduled for a particular time period. Therefore, these replacement costs are purely based on the particular time span or the lifetime of the building system. So we can use the same sources that provide the cost estimates for initial investments to obtain estimates of replacement costs and whatever the expected useful lives. So for an example, a good starting point for estimating future replacement costs is to use their cost as of the base date. That is what we call as the present value of the replacement costs. So the life cycle cost analysis, the LCCA method, will escalate the base year amounts of their future time of occurrence. So whatever the costs that will be happen in future, we should convert it into the present value or the base year value. Anything that you need to clarify before moving forward? Okay, it seems we don't have any other questions so far. So moving forward, when calculating these life cycle costs, we need to focus on the present value analysis. So there are several parameters that we should consider when we do this present value analysis. So this present value analysis, most important parameter is the discount rate. So you will see almost in all the questions there's something called as a discount rate. So in order to be able to add and compare the cash flows that are incurred at different times during the life cycle of a project, they have to be made time equivalent. That means to make cash flows time equivalent, the LCC method converts them to present values by discounting them into a common point in time, usually what we call as the base date. The interest rate used for discounting is a rate that reflects an investor's opportunity cost of money over time, meaning that an investor wants to achieve a return at least as high as that of his or her next best investment. Hence, the discount rate represents the investor's minimum acceptable rate of return. So in order to be able to add and compare cash flows that are incurred in different times during the life cycle of a project, they have to be made time equal. That is due to the inflation. So $1,000 today will not be equal to $1,000 in 1 month time. So we need to be time equivalent. The value should be time equivalent. To make these cash flows time equivalent, in the life cycle cost method, it converts them into the present value. So we basically convert any cost into the present value by discounting them to a common point in time. That is, usually we call it as the base date. So the interest rate used for discounting is the rate that reflects a particular investor's opportunity cost of money over time, meaning that an investor wants to achieve a return at least as high as that of her next best investment. Hence, the discount rate represents the investor's minimum acceptable rate of return. I hope it's clear for you. Moving forward, so in order to select a discount rate, we should know how to do it. For that, the estimated cost inflation should be considered when evaluating the future cash flows. As I said, these discount rates are purely based on the inflation rates. So in order to identify or select the discount rates, we should first estimate that the cost inflation should be considered when evaluating these future cash flows. Let's say a cost in 1 year should be equal to the cost in base year multiplied by the inflation. So the discount rate reflects the investor's opportunity cost. That means the rate of return the investor could earn in the marketplace on an investment of comparable size and risk. That is the average cost of capital. So in order to treat this inflation in life cycle cost analysis, it can be performed in constant dollars or current dollars. Constant dollar analysis excludes the rate of general inflation. So we basically exclude the general inflation rate, and the current dollar analysis will include the rate of general inflation. That is the main difference between constant dollar analysis and the current dollar analysis. In the constant dollar analysis, we don't bother about the rate of general inflation. But in current dollar analysis, we include the rate of general inflation in all dollar amounts or maybe rupee amount. So these discount rates and the price escalation rates as well. So both types of calculations result in identical present value life cycle costs. So in constant dollar analysis, it is recommended for all the federal projects, except for the projects financed by the private sector. So in terms of all the government projects, it is recommended to go for constant dollar analysis. But for private projects, it is always recommended to go for current dollar analysis. Because the constant dollar method has the advantage of not requiring an estimate of the rate of inflation for the years of the study period. The alternative financing studies are usually performed in current dollars if the analyst wants to compare the contract payments with actual operational or energy cost saving from year to year. So when it comes to this life cycle cost estimation, in a previous slide, I just showed you a very simple formula that we can use for the life cycle cost analysis. If we advance it further, you can go for a formula like this. But again, this is not the only formula that we can use. As I said before, depending on the data given or the information given and the situation, the parameters of this formula might change. So the life cycle cost is equal to, according to this equation, it is equal to I is the present value of investment cost. That is the value of the investment in the base date. And REPL representing the present value of the capital replacement costs. RES representing the present value of residual cost or the residual value, whatever the salvage value or the resale value. E is standing for the present value of the energy cost. W for the present value of water cost. OM&R is the present value of non-fuel operating, maintenance, and repair costs. O for the present value of any other costs. So by looking at this formula, you can see all the values are taken as the present values. That is because of we are referring to the value of the base year. Are we clear up to this point before moving forward? Can someone confirm? Do we have anything to be clarified before moving into the questions? The examples? Okay, if you don't have questions, we can move on to the next slide. The purpose of life cycle cost analysis. Why we need this life cycle cost analysis? It is mainly because of three reasons. One is to choose between two or more alternatives. So if we have two or more alternatives, we can choose what is the best thing or the best alternative to be chosen using this life cycle cost analysis. Second, to determine the assets benefits. So what are the benefits that we could get through a particular asset? And also to create accurate budgets. So in order to create accurate budgets, we can also choose this life cycle cost analysis. So moving forward for an example. So let's try to do this example. So this is a very important example, guys. So students, please try to do this example on your own in the class, within the class, and I'll discuss some steps in between the in between where when you are trying to do this example as well. So in this example, it is regarding purchasing a new vehicle for a construction company. So a construction company is planning to buy a vehicle to one of the top level managers. There are two main options or two main alternatives that the company can select. The costs incurred with each option is listed in the table here. Both vehicles will be used for a period of 5 years. So one option is go for a fuel car. The second one is going for a hybrid car. So if you go for a fuel car, it can be sold at $8,000 at the end of 5 years. If you are going for hybrid car, it can be sold to $10,000 after 5 years. Your task is to identify the best alternative to be selected. Can you first try to do this example on your own? So they have given the purchase price of the fuel car and the hybrid car, the fuel usages, the miles per gallon, and the annual fuel cost is given. Average maintenance costs are given. Salvage value, that is the value that we can sell the vehicle after 5 years. The insurance per year and the tax rebate also given. Apart from that, miles driven per year, regardless of whatever the car that you are using, the miles that driven per year and the average price per gallon is also given, and the discount rate as well as the inflation rate. So based on these information, can you try to identify the life cycle cost for fuel car and the life cycle cost for the hybrid car? So based on those life cycle costs, can you select the best alternative to be chosen? If you have any questions, you can just raise in maybe in the chat, or maybe you can unmute yourself and ask the question as well. We have an answer from one student. Let's see what is the answer from others as well. Apparently, the answer is wrong. The person who answered, the answer is not the correct answer. But appreciate that you have tried to give an answer. I'll help you a bit. So when you have a question like this, what you should do is actually, first of all, you should calculate the life cycle cost for each alternative, that is for the fuel car and the hybrid car. So for that, you can create a table like this. So it says for up to 5 years. So therefore, our lifetime should be from year 0 to year 5. Year 0 is the current base year. For year 5 is the maximum span. And based on the given data for the fuel car, you can fill the acquisition cost, the fuel cost, maintenance costs, likewise for each and every year. So you might have only single acquisition cost, which is in year 0, but for each and every year, you will have a fuel cost and a maintenance cost as well as insurance cost. So try to fill this table and then identify the present value. So if you try to write down the acquisition cost, will be only in the first year. Since it is a cost, we are taking it as a negative value. So the acquisition cost for the fuel car is 17,000. Right here we will have 17,000 as the acquisition cost. Then do we have any fuel cost at the base here? No. Like when we are purchasing the car, we don't have fuel cost, we don't have maintenance cost, we don't have insurance cost or any other costs. So annual cash flow at the moment we are buying the car should be equal to this 17,000. So carefully follow these steps. Right. So in order to calculate the annual cash flow, actually what should be done is we should take the difference of total O&M cost. That means total O&M cost is the sum of fuel cost, maintenance cost, and the insurance cost. So this total O&M cost minus the tax or the salvage value is equal to annual cash flow. So for the year one, do we have any acquisition cost? No, because it has now already been acquired. So for the year one, the full cost based on the given information, the miles driven per year is 25,000 and the usage of fuel for the fuel car is 24 gallons per mile, miles per gallon. So in order to go 25,000 miles, how many gallons needed? 25,000 divided by 24. And the average value per or average price per gallon is $3. So you can easily calculate the fuel cost for year one. The fuel cost for year one is equal to 25,000 divided by 24. 25,000 divided by 24, and this should be multiplied. So 25,000 divided by 24 is basically giving me the 25,000 is the miles driven per year. 24 is the fuel usage, that is miles per gallon. So how many gallons needed is can be calculated by 25 divided by 24. If we multiply it by the average price per gallon, I can easily multiply this by the average price per gallon. So it is equal to how much? 25,000 divided by 24 multiplied by 3. So I am getting an answer of 3,125. Still, this is not the correct answer because I should consider the inflation as well. So inflation is given as 3.5%. So whatever the amount 3,125 in 1 year will not be equal to 3,125 in the present value. It should be higher than that. So to calculate that thing, I should multiply this answer by 3.5%, in the sense it should be 103.5. So whatever the amount here should be multiplied by 3.5%, that means 0. So whatever the amount we have here should be multiplied by the 3.5% percentage. So the easiest way to do this is 103.5 should be the new value if you divide it by 100. So you will get the answer of, which is equal to 3234.38. So did you understand how I got this answer? 25,000 is the miles driven per year. Either you are using the fuel car or the electric car. And 24 is the fuel usage miles per gallon for the fuel car. So I've divided 25,000 by 24. It will give me the number of gallons needed for fuel car. I multiplied it by 3 in order to calculate the total price for the fuel gallons. And I multiplied it by 103.5 and divided by 100 just to make sure that the inflation is also counted. Clear? So I will do the rest for the year 1. So you can continue this work and get the answer. So to calculate the maintenance cost, what I can do is I should know the maintenance cost per year. As per the given information, the average maintenance cost of the fuel car is 250. But if taking the inflation into consideration, 250 multiplied by 103.5 divided by 100. So it basically gives me the answer of 258.8. So I'll write it down as 259. Clear? Then for the insurance cost, so I hope it's clear for you, even though I just followed these steps, because in order to get an understanding on how to do it, you need to know how to calculate this. Otherwise, I can just put the answers, so you might not know how to get the answers. For the insurance cost, as per the given information, they says insurance per year is 950, but taking into consideration, we should take the inflation into consideration as well. Therefore, this should be equals to 950 multiplied by 103.5 divided by 100. So it simply gives me an answer of 983.25. So let's say it's equal to 983. So here I have identified the fuel cost, the maintenance cost, and the insurance cost. So now I can easily identify the total O&M cost by adding these values together. So this O&M cost is equal to 3,234.38 plus 259 plus 983. So this is equal to 4,476. After identifying the total O&M cost, do we have any tax rebate for the first year? No. Any salvage value for the first year? Since we don't sell the vehicle after the first year, we don't have any salvage value. Therefore, the annual cash flow should equals to total O&M cost minus tax or the salvage. So since we don't have tax or salvage, we can directly write down the answer for the annual cash flow as well. 4,486. So we have identified the annual cash flow. So after identifying the annual cash flow, in order to calculate the present value, so it is very important for the first year or the start of the period. Anyway, the present value is as it is 17,000. But for the first year, if you remember how to calculate the present value is equal to the cash flow divided by 1 plus I into N. So if I write you the formula, the present value is equal to, if you remember, we learned it in the previous lesson as well, the cash flow or the annual cash flow divided by 1 plus whatever the interest or the discount rate into the power of number of years. So if you use this formula to identify the present value, so you will divide 4,486 by 1 plus the interest rate or the discount rate is 0.1 or the 10%. Therefore, this is equal to 4,486 divided by 1 plus 0.1 to the power of 1. So this basically gives you the answer of 4,078. If I have any calculation errors, just let me know. So anyway, this is the method you should follow in order to get the answer for each and every year. Since this is a cost, you should put the, you should put these brackets as well. So these brackets simply indicating that these are costs, negative values. Are we clear on this year 1 calculation? Can you do the year 2 calculations alone now? Okay, why we get 103.5 over 100 instead of 3.5? Okay, good question. It's like this. So 103.5 over 100 in the sense, what basically happens there is, if it is 100 rupees today, it will be 103.5 rupees in that particular year. That is due to inflation. So whatever the, like, let's say for an example, sorry. Let's say for an example, 100 rupees in first year, year one. 100 rupees in year one is equal to, this should equal to more than 100 rupees in base year, right? Because due to the inflation anyway, the rupee should be depreciated, or the dollar should be depreciated. So 100 rupees in year one should be greater than the whatever the amount in year zero, or the base year. So to calculate the year zero amount, this 100, so whatever the amount should be divided by 100 and multiplied by that particular value. So that particular value is 103.5, because the inflation rate is given as 3.5%. So 3.5% in the sense, as a percentage, this is 3.5. So for 100, there will be a 3.5% inflation. So 3.5% will increase will have to 100. That means it should become 103.5. Is it clear now? That's why I divide 103.5 by 100 in order to get the present value. If you multiply this by 3.5, obviously you are getting an answer which is 3 times greater than the actual value. Okay. Any other questions? So can you do the rest of the years and identify the net percent value for each and every year? So after identifying the percent value for each and every year, what you should do is, to identify the LCC value, or the life cycle cost, you should simply take the sum of these percent values. Be careful, if those are costs, you should have the brackets. If it is a profit, you should have a positive value. You would probably have a positive value for the year 5, because at the end of year 5, you are going to sell this particular vehicle, or the salvage value will be there. Because of the salvage value, we know that annual cost is equal to the salvage value. So sorry, annual cost is equal to the total O&M cost minus the salvage value. Since we have a salvage value, we will have a positive answer here. Right? So simply what you should do is, you should take the epsilon value, or the sum of these percent values, to identify the life cycle cost. So you will identify the life cycle cost for the fuel car, and you will repeat the same steps for the hybrid car. After identifying both life cycle cost for both cars, whatever the vehicle with the low life cycle cost will be the best alternative solution. Are we clear? Any questions that you need to clarify? Anything? Or is it okay if I erase the annotations here? How does the calculation change with the second year? Okay, I'll do another year for you. So I will erase this part, or maybe I'll erase the annotations we have in the screen now. I hope you have already noted down those things. Okay, so here comes the year 2. Year 2, do we have any acquisition cost? No. When it comes to the fuel cost for year 2, so the fuel cost should equals to the average fuel cost per year is we calculated it as 25,000 divided by 24 multiplied by 3. But for the second year, now the inflation rate should be twice as that. Per year, it was 3.5%, but for the second year, 2 times 3.5%. So I will just put the answer here without doing the calculation, so you can do the calculations. So you should get an answer of 3,347.6. It is for the second year. Sorry. So for the second year, it should be 3,347.6. Not the acquisition costs, it is the fuel cost. So similar, the maintenance cost, you should get an answer of 268. For the insurance cost, you should get an answer somewhere around 1,018. So you can easily get the total O&M cost by adding these values. So it will get an answer of 4,633. Do we have any tax rebate in the second year? No. Any salvage value? No. Therefore, the annual cash flow will be similar to the total O&M cost. That is again 4,633. Therefore, the percent value, so you should do the calculation again. In this time, it should be cash flow divided by 1 plus 0.1 into the power of 2 because this is second year. So you'll get an answer of 4,211 or 12. 4,212. It is again a cost. Okay. Clear now? Okay, so you should repeat the steps for year 3, year 4, and year 5. Then you will get the percent value for each year. By taking the sum of those percent values, you will be able to identify the life cycle cost for fuel car. Similar steps should be repeated to the hybrid car as well. So repeating the similar steps, you will get the LCC or the life cycle cost for the hybrid car. Then you can compare those two life cycle costs and identify what is the best alternative to be used. So the best alternative should have the lowest life cycle cost. So by getting that, you should probably get the answer of hybrid car as the lowest life cycle cost. But the only thing we need to highlight here is, even though the hybrid car is having a higher purchase price here, when you compare the life cycle cost, the hybrid car is having a higher life cycle cost. Sorry, lower life cycle cost. Since the hybrid car is having a lower life cycle cost, even though its initial price or the purchase price is higher, it is the most optimum solution or the alternative to be used. Are we clear? Anything that you need to clarify before winding up the session? I think you have another lecture by 10:30. No questions? Okay, we can wind up the session for now, and we'll be again meet on next week, probably for the next lesson. So I will upload these lecture notes for the LMS. So you can do this example again and again, and this I might include some more examples to the end of this slide, so you can try them uh, independently as an homework as well. Thank you for your cooperation, guys. We'll again meet on next week. Have a nice day.